Greetings from K.S.Rangasamy College of Technology. Myself, B. Balaji, working as assistant professor in the Department of Mechanical Engineering at K.S.Rangasamy College of Technology, Tiruchengodu. I am handling the design of machine elements subject. Today, we are going to discuss about the topic of steady stresses and variable stresses in machine members under the module of design. First, we are going to discuss about machine design. Machine design is the creation of new and better machines and improving the existing ones. A new or better machine is one which is more economical in the overall cost of production and operations comparing to the existing machines. The process of design is a long and time consuming one. From the study of existing ideas, new idea to be conceived. The idea is then studied keeping in mind its success and given shape and form in the form of drawings. Next, we are going to see about engineering design. Engineering design is a process of applying various scientific principles and techniques for purpose of defining in detail a product or a process or a system to its realization. In other words, we call it as design is formulation of a plan or for execution towards satisfying your needs. Machine design is defined as to fix dimension for machine components. So these are the various design processes steps. So first step is need or aim. Second step is synthesis mechanisms. Third step will be analysis of forces. And then fourth step is material selection. Fifth one is design of elements. Next step is modification. And next step is detailed drawing. Last one will be a production. So these things we will see detailed in the next slides. First, step 1, recognition of a need. First, we have to identify the customer needs through market research. Second step is definition of the problem. For that, we have to prepare a complete list of technical specifications. Third step is synthesis. In synthesis, we have to collect the new ideas and or otherwise may modify the existing ideas. Fourth step is analysis. The forces acting on the component are determined. The material of the component is selected. The geometric dimensions of the component are determined. Next step is evaluation. The possible success of the proposal should be verified from technical and economical standpoints. Next step is detailed design. It's the actual sizing and dimensioning all individual components in the part. Next one will be a prototype and testing. So prototype and testing may lead to some modification. Through that, we came to know that there is some difficulties in it. So we make some modifications in it. Last one, actual component manufactured at shop floor. This is done in the production area. So next topic is types of machine design. In that, first one is adaptive design. The designer only makes minor alteration or modifications in the existing designs of the product. Second one is development design, modifying the existing designs into a new idea by adopting a new material or different method of manufacture. Third one is new design. This type of design needs a lot of research, technical ability and creative thinking. Fourth one is empirical design. So this type of design is based on the empirical formula, based on practice and past experience. So these are the some of the classifications of design. First one is optimum design. It is a design best design for given objective function under the specified constraint. Second one will be system design. To develop a system that will meet expected needs within realistic constraints such as economical environment, social, political, ethical, safety and sustainability. Third one will be element design. In element design, only we are going to see about design of machine elements and then design of mechanical transmission systems. So these subjects are comes under the element design. So in the design of machine elements, we will see such parts like piston, crankshaft, gear. So these things and all we are going to design it. Next one will be computer aided design. Use of computer system to assist in the creation, modification, analysis and optimization of a design. When compared to the manual design, computer aided design is less time consuming process. So these are the factors influencing machine design. First one will be safety, second one will be reliability, third one will be quality, fourth one will be productivity, fifth one will be cost, sixth one will be ecological consideration, seventh one will be availability of men, material and machines. Next one will be environment, and the next one will be conservation, energy conservation, and then last one will be space constraints. Next, we move on to general considerations in machine design. Basically, we have to consider these things while designing the products or parts or components, whatever it is. First one will be type of load and stresses caused by the load. Second one will be motion of the parts or kinematics of the machine. Third one will be selection of materials. Fourth one will be a form and size of the parts. Fifth one will be frictional resistance and lubrication. Sixth one will be convenient and economical features. Seventh one will be use of standard parts. Eighth one will be safety of operations. Ninth one will be facilities. 10th one will be machines to be manufactured. 11th one will be cost of construction. So these things we have to consider while designing the parts. Next one will be design rules. So while we designing the parts, we have to follow some rules. First one will be design should aim at the best with the least expenditure. Second one will be a component should have adequate strength, wear resistance and corrosion resistance. The assembly should be backlash free. Resonance is to be avoided. The design should be simple, foolproof, easy to operate and should reduce operators' fatigue. The designer should need only a minimum maintenance. Last one will be dimensions of the components should be rounded off to the standard values. Next one is engineering materials. First, in that there are two types. One will be metals, second one will be non-metals. In metals, again there are two types. One will be ferrous and another one will be non-ferrous. In ferrous, it contains the iron as the major constituent. Example, steel, cast iron. When you move on to non-ferrous metals, materials does not contain iron. Example, copper, aluminum. Next we move on to non-metals. In that, first if you are using the ceramic materials means oxides, carbides, nitrites of various metals. Example, brass, brick, concrete, cement. So these are comes under ceramic materials. Next, polymeric materials composed of carbon components. Example, paper, fuel, rubber, paints, etc. Next topic is factors to be considered for the selection of materials. While we are selecting the materials, we have to consider some of the factors like availability of material, and then second one will be cost of material, third one will be physical properties, fourth one will be mechanical properties, fifth one will be manufacturing process. So what are the manufacturing process we are going to follow? So these things to be considered while selecting the material. In physical properties, we have to consider some of the points. First one will be color, second one will be electrical conductivity, and then shape, and then thermal conductivity, and then density. So these things we have to consider while selecting the materials. Next topic is stress and strain. Stress. The internal resistance of force per unit area is called as stress. Sigma equal to P by A. Sigma means stress. P, load or force acting on the body. A means cross-sectional area of the body. Next one is strain. The rate of change of deformation is called as strain, or otherwise it's the ratio of change in dimension to the original dimension. E is equal to del L by L. The relation between sigma E del L is deformation means del L equal to PL by AE. So next we move on to types of stresses and strains. First one is tensile stress. The stress induced in your body when subjected to two equal and opposite pulls, as a result of which there is an increase in length, is known as tensile stress. The ratio of increase in length to the original length is known as tensile strain. Formula for tensile stress is resisting area by cross-sectional area, which is equal to P by A. Formula for tensile strain is increased length by original length, which is equal to del L by L. Next one is compressive stress. The stress induced in your body when subjected to two equal and opposite pushes of a, as a result of which there is a decrease in length of the body, is known as compressive stress. The ratio of decrease in length to the original length is known as compressive strain. The formula for compressive stress is resisting area by cross-sectional area, which is equal to P by A. Formula for compressive strain is decrease in length by original length, which is equal to del L by L. Next one will be a shear stress. The stress induced in your body when subjected to two equal and opposite forces which are acting tangentially across the resisting section, as a result of which the body tends to shear off across the section, is known as shear stress. The corresponding strain is known as shear strain. Formula for shear stress is shear resistance by shear area, which is equal to P by A. Formula for shear strain is transverse displacement by distance equal to del L by L. Thanks for watching. Keep learning and growing. Thank you.